What is acoustic propagation in a skyquake phenomenon? Imagine hearing a loud boom in the sky on a clear day, with no clouds or storms around. That's what a skyquake sounds like, but what actually causes those mysterious noises? To understand this, we need to look at how sound travels through the air after being generated by unusual sources. Acoustic propagation is the process of sound waves moving through the atmosphere. When a skyquake happens, it's often linked to seismic activity deep beneath the Earth's surface. For example, an earthquake or a small seismic event can cause the ground to shake suddenly. This shaking pushes air upward, creating pressure waves that move through the air like ripples on a pond. These waves are what we hear as booming sounds in the sky. The way these sound waves travel depends on the properties of the air, such as how dense it is and how warm or cool it is. When seismic waves reach the surface, they can generate acoustic waves that shoot upward. These waves spread out in all directions, but their speed and strength change based on atmospheric conditions. For instance, wind layers or temperature differences can bend or amplify these sound waves, making the skyquake louder or more distant. Sometimes, the waves behave like acoustic gravity waves, which combine sound with buoyancy effects in the atmosphere. These waves can travel very far and even reach high altitudes, where they can be detected by special instruments. Only a tiny part of the seismic energy turns into these atmospheric sound waves, less than 0.1%. As the waves travel, they gradually weaken because of friction in the air and spreading out over larger areas. Certain ground or atmospheric conditions can make the sound louder locally. Soft soil layers above bedrock can help transfer seismic energy into the air more effectively, creating a louder skyquake. This process shows how the Earth's vibrations can turn into strange sky noises, even without weather or explosions. Studying how these sound waves move helps scientists understand both seismic activity and atmospheric physics better. It also helps improve how we detect earthquakes or volcanic eruptions by listening for these sky noises. So, in essence, acoustic propagation in a skyquake is how seismic energy becomes airborne sound waves that produce those eerie booming noises in the sky. The journey of these waves is shaped by the Earth's vibrations and the atmosphere's conditions, creating a fascinating link between the ground and the sky.